Hello viewers, welcome to video number 68 of channel Chemphilic. Video number 68 is the 10th episode of chemical thermodynamics, and the topics of this 10th episode of chemical thermodynamics is first law of thermodynamics. So let's start. First law of thermodynamics is known as the law of conservation of energy. What is that? We know that energy cannot be created nor being destroyed, just it can be converted from one form to another. Now the same statement, that is the energy cannot be created nor be destroyed, can be stated in different ways. Therefore, this first law may also be stated as number 1, the total energy of an isolated system remains constant although it can undergo a change from one form to another. Remember, here isolated system means just we consider that our system, and this is our system, and this is the heat reservoir. So, and everything is insulated. That means this system, say it is a gaseous system, it can take heat from the reservoir or it can release heat to the heat storage or reservoir. That means this heat exchange takes place only with this system and this reservoir. So, what is this one? Total energy of the isolated system, that means total energy of this system and the surrounding is constant, but it can undergo, although it can undergo change from one form to another. Say total energy is 100. So here say 70 calorie, here 30 calorie. Okay, it will be constant total 100, or say 50-50. Always it will be constant because it is an isolated system. I told you that system attached with the heat reservoir or heat storage, and then just imagine it is insulated. That means system can exchange heat only with this heat reservoir. Okay, and this energy can be converted from one form to another. That means it can undergo a change from one form to another. Now, next statement, whenever a quantity of some form of energy disappears, an exactly equivalent amount of some other form of energy appears. Same thing, energy cannot be created nor be destroyed, but it can be converted from one form to another. That's why whenever one form of energy disappears, definitely any other form of energy will appear. Next point, next statement. It is impossible to construct a perpetual motion machine, that is a machine which would produce work continuously without consuming energy. So, no machine can produce work without consuming the energy, because work means, what is work? Work is also one form of energy. So, when you are producing energy, that means you have to supply the energy. So, there is no machine which can form the work, which can give the work or form the energy without consuming the energy. That means energy is converted to work, another form. Next statement, for a system in contact with its surrounding, some of the energies of the system and surrounding at a particular time remains constant. Howsoever differently it may be shared between the two. Already this point I told here. Say it is the system, isolated system, and I told you what is my isolated system. This system can exchange heat only with this heat reservoir or this heat storage. Already I told you, suppose total energy is 100 calorie. It may be say 50-50, 70-30 or here 40-60, whatever it is. It may be shared in different way, but the total energy will remain same, that is 100 calorie, what I have considered here. Now the next statement. All of us know that Einstein established the fact that energy can be produced by the destruction of mass, and the two quantities, how they are related? It is very well known equation, E is equal to mc square. Then what does it mean? Energy can be created from the mass. But first law of thermodynamics is telling that energy cannot be created nor being destroyed, only it can be converted from one form to another. Then is it contradiction to this first law of thermodynamics? No. This is not in contradiction with the first law of thermodynamics. Why? Because mass is considered as some kind of potential energy or one form of potential energy. That means energy is created from the mass means some form of energy, this potential energy which is considered as mass, means mass is considered as some form of potential energy that is converted to other form of energy. So this first law of thermodynamics or this law of conservation of energy may be modified in this way that total mass and energy of an isolated system remains constant in chemical thermodynamics. We are not telling only energy, mass and energy, though we know that mass is one form of potential energy, that means energy only, but it can be stated like that. Total mass and energy of an isolated system remains constant in chemical thermodynamics. Okay. So this first law of thermodynamics, which is the law of conservation of energy, that is energy cannot be destroyed, cannot be created, only it can be transformed from one form to another, that can be stated in all these different ways, because all the statements are telling the same thing, law of conservation of energy. Now coming to the important things, that is the mathematical formulation of first law of thermodynamics. Okay. Now just let us consider this is a gaseous system which is enclosed in this cylinder, and this cylinder is attached with this piston which is movable. Okay. And the stationary condition, pressure of the gas which is acting upwards is equal to the external pressure which is acting downwards. External pressure, here it is atmospheric pressure and weight of this piston. Okay. Now under this condition, piston is in the stationary state, external pressure is equal to gas pressure. Now under this condition, if you heat the gas, that means you are supplying energy to the gas. So when the energy is supplied to the gas, then what will happen? Internal energy of the gas will increase, and this gas will perform some pressure volume work, already I have discussed, so that it will move the piston from this position to this position. That means expansion occurs, and expansion means work is done by the gaseous system. Okay. So heat absorbed at constant pressure, it goes to increase the internal energy of the system. This internal energy, already when I discussed about energy, I told you this internal energy, it depends on the chemical nature of the substance and temperature, pressure, volume. It is the inherent property, and already I told you this is the microscopic level of energy. Once again I will make one video on internal energy, there I will explain in details. And this internal energy, when the energy is absorbed, that is heat is absorbed at constant pressure, this internal energy of this, here I have taken gaseous system, internal energy of the gas increases, plus this gaseous system will perform some pressure volume work by moving the piston, that means by expansion. So this is plus, and we know that work done by the system, that means it is giving energy to the surrounding, that sign is negative. So delta E plus this work done by the gaseous system. And internal energy, one more thing you remember, that when that internal energy, it represents the temperature. That means internal energy increases means temperature increases. Internal energy decreases means temperature decreases. Okay. So what we can write from this? We can write delta E. E represents internal energy. Delta E represents change in internal energy. As here the gaseous system absorbs energy, internal energy increases, because temperature will find temperature will increase. Okay. Internal energy change shows that change in the thermal energy. So temperature here it will increase because internal energy is increasing. This internal, so internal energy is equal to, this is plus sign, because when heat is absorbed then sign is positive, when it is released then sign is negative. So we can write plus QP, that is heat absorbed at constant pressure. Constant pressure means against this constant external pressure. Gas is working under constant external pressure. Okay, minus W. This is the formulation of this first law of thermodynamics. Okay. So heat absorbed at constant pressure goes to increase the internal energy of the system, and also the system performs some pressure volume work. So we can write, therefore heat absorbed at constant pressure goes to increase the internal energy of the system, at the system performs pressure volume work. Internal energy of the system, once again I am telling, here I have taken, here it is gaseous system. So whatever heat is absorbed, it is divided into two parts. One part is increasing the internal energy, that is microscopic level of energy, which is the inherent property, and which represents the thermal energy change in internal energy means thermal energy change or temperature change, plus the system performs the pressure volume work. So whatever heat absorbed, divided into two parts. One, increasing internal energy. Second, performs the pressure volume work. Now, similarly, what we can write? Heat release at constant pressure. Heat release at constant pressure. What it will be? Heat release means here it will be minus QP under constant external pressure. Okay, it will decrease the internal energy because heat is releasing here, and so delta E plus, when the heat will be released, when the gas is compressed, that means this piston is compressed, so there will be a decrease in the volume. Initially it was increase in the volume, it was V1 and then this was V2. Compression means piston is moving down. So, volume decreases. So, therefore, delta E plus of W, because work done on the system, that sign is positive. So, what we can write? Delta E is equal to minus QP plus of this work done on the system when heat release at constant pressure. Okay. So now this work is the pressure volume work, and what we have observed that this QP, say heat absorbed, here I am considering absorbed, heat absorbed at constant pressure, that is equal to delta E plus this pressure volume work done by the gas. And this pressure volume work is, we know that P delta V, already I explained, that is constant pressure and into the change in the volume, or here it is absorbed means this expansion, how much volume expanded, that is V2 minus V1. So, from here, what I can write? QP is equal to delta E is the change in the internal energy. Here, I am representing internal energy by E. You can represent internal energy. In some books, you will find that internal energy can be represented either by E or by U. Okay, here I have taken E. So, this heat absorbed at constant pressure, change in internal energy, that means final state internal energy minus initial state internal energy. Initial state means before absorbing the heat. Final state means after absorbing, that means after expansion. Here I have considered the expansion. E2 minus E1 plus P, constant external pressure, into V2 minus V1. So, what we can write? QP is equal to E2 plus PV2 from this. Then, minus if I take common, then it will be E1 plus PV1. Now, this E plus PV, see, here it is E2 plus PV2, then E1 plus PV1, then this E plus PV, it bears another characteristics property of the system, and this is known as enthalpy. Very important. I'll make one more video on this internal energy and enthalpy also. So, known as enthalpy or heat content. This is enthalpy, which is denoted by H. Enthalpy, or it is also known as heat content. This enthalpy indicate the total energy stored in the system. Okay, total energy means this internal energy, which is the microscopic level of energy, which is the inherent property, and the energy for this pressure volume work. Work also nothing but the transfer of energy. So, the total energy, internal energy plus the energy transfer through work. Okay. So, this E plus PV, that is the enthalpy or heat content. So, therefore, from this equation, what can I write? QP is equal to this P2 plus PV2, E2 plus PV2, I can write it as H2, that is enthalpy in the final state, minus enthalpy in the initial state, final minus initial, that is change in enthalpy. So, according to first law of thermodynamics, what I can write, heat absorbed at constant pressure goes to increase the enthalpy of the system. Enthalpy of the system. Okay. Similarly, heat released at constant pressure goes to decrease the enthalpy of the system. Enthalpy is the total energy content or total energy stored in the system or in the body. So, this is the mathematical formulation of this first law of thermodynamics. Now, some special properties of first law of thermodynamics I will discuss in my next video. Hope you have understood. Thank you.